Okay, today in pre-cal we talked about increasing, decreasing, maximum, and minimum of polynomial fractions. The first definition we talked about is if there is a positive change in x when moving from left to right, that is an increase. If there is a negative change in x when moving from left to right, that is a decrease. Increase, for example, would look like this. Decrease would look like this. The next word is constant. If there is zero change in the graph, we know it's constant. And finally, there's a new word probably for you, which is called monotonic. And that means it is either always increasing or always decreasing. Monotonic should make sense to you because mono means one. Let's look at some graphs. Number one, f of x is equal to x cubed. Now, I'm just going to show you the graph of this because today that's not our focus, so I'm not going to spend time helping you plot points and all that. You can always use a calculator, so that should be fine. When I look at that graph, if I'm trying to figure out if it's increasing, decreasing, or constant, I'm going to start from left to right like I read and see what's happening. If this was a hill, I'd be climbing it. It changes its shape at 0, but it's still increasing. So this is increasing from negative infinity to infinity. Now, you might be thinking to yourself, well, this arrow is going down, so it's decreasing. Well, no, it's not, because I'm moving from left to right. When I'm talking about increasing and decreasing, I only care about my x values. So that's our answer. And since it's only doing one thing from negative infinity to positive infinity, it is monotonic. There you go. Number 2 is x cubed minus 3x. This one is a little bit more precise because it crosses at the point negative 1, 2. There's a point there. And at 1, negative 2, there's a point. And it looks like this. It's kind of a rough sketch. If I start from left to right, from negative infinity all the way to negative 1, remember I'm looking at the x value, it is increasing. Then right here it changes and it starts to decrease. From negative 1 all the way till the x value is 1. Then here it changes again and this begins to increase, so from 1 to infinity it is increasing. Notice I'm only using x values. Also, I'm always using parentheses, no brackets when it comes to increasing, decreasing, constant. Number 3, f of t. This is going to be a piecewise function like we talked about earlier this week, which is t plus 1 when x is less than 0, 1 when x is between 0 and 2, and negative t plus 3 when x is greater than 2. So that's our 3 things that are going on. I'm going to go ahead and show you the graph. Again, if you wanted to graph it or if you needed to graph it, you know how to do that, but that's not the main focus of today, so I'm just going to give it to you today. It would come in from here, stay constant until 2, and then decrease like this. If I look at my intervals of increasing, decreasing, and constant, from negative infinity to 0, it is increasing. From 0 to 2, it is constant because it's a straight horizontal line. And then at 2, it starts decreasing. So from 2 to infinity, it is decreasing. Make sure that answer's in your view. Also, guys, if somewhere there is something that is not in the domain, meaning there's no graph going on, then it's not increasing, decreasing, or constant. It's nothing. You don't even need to worry about it. So that's one piece of that. Let's move on now to maximum and minimum. Maximum and minimum extrema are what they're called. Okay? And there are 2 types of extrema. I think I probably just put extrema here. The 2 types are the local and the global. Okay? The local and the global, or the absolute, are the 2 words there. Okay, if I look at a graph like this, look at my notes again, I'm getting sidetracked. This could also be the relative. If I look at something like this, and I label my points A, B, C, D, E, F, and G. When I'm thinking about what the local and the global are, okay, and I'm going to try to put some emphasis on that being the lowest one. Okay, if I think about local things versus global things, today we talked in class about, if I'm talking about a theme park, the best theme park locally is probably Six Flags. The best theme park in the world is probably Disney World. Okay, now that's just my opinion, so that's aside at this point. But if we lived in Orlando, we would not think Six Flags was the global. We would still think Disney World was, okay? And so it depends on where you are, whether we're talking about local or global. In the graphs, local is anywhere where it's the highest or lowest point. Global is the absolute highest point on the graph and the absolute lowest point on the graph. So let's list our local max and min. Local maximums would be anything that's a maximum. A would be a minimum. B would be a maximum. C would be a minimum. D would be a maximum. E would be a minimum. F would be a maximum. G would be a minimum. And when I say it's a minimum, I mean it's the lowest point around. These points are both higher. When I say it's a maximum, it's the highest point around. These points are both lower on either side of it. So that's our local max and min. Now for absolute max and min, I want to know the very highest and the very lowest. The very highest is probably B. The very lowest is probably C. And so that's our absolute maximum and minimum. I want to look at one more example. This is example 5, and it says f of x equals 3x squared minus 4x minus 2. In your calculator, you're going to go to y equals, and you're going to plug that in. Then you're going to hit graph, and look at the graph. When you look at it, it's going to be a parabola that looks something like that. Now, to figure out what this absolute minimum is, it's both a local and an absolute. To figure out where that point is, we're going to hit second, trace, and in this case it's a minimum. So I'm going to hit 3 because that's a button for minimum. If it was, let me get my camera in view here, if it was the maximum, it would be 4. So I'm going to put 3 or 4. It is the minimum, so I'm going to do second trace. And the important thing for you to realize here, as I grab my calculator, is that it matters which side is to the left or to the right. So I'm going to get here. Hopefully you can see. If not, you can look at your own calculator. If it says it's on the left, notice my little clicker is to the left side of the minimum. If it's not to the left side, you're going to get a wrong answer or an error. So be sure it's on the left and hit enter. The next question says right bound. So I'm going to move to the right. Move the clicker to the right of the minimum and hit enter. Finally, it says guess. Hit enter one more time. It's going to give you an answer. The x is 0.666, which is 2/3, and the y is negative 3.333, which is negative 3/3. So that is our minimum at 2/3, comma negative 3 1/3. If you have questions, let me know. That's the end of our notes today.